I want you to imagine with me a world where small observations can change the course of history. 1950, Dr. Lawrence Craven noticed that patients taking aspirin had lower rates of heart attacks. Countless lives saved. 1964, when testing propranolol, they discovered its antihypertensive properties. It was being tested for angina. And from that observation, we have beta blockers for blood pressure management. Again, countless lives saved. Fast forward to 1987. Botox was being used to treat involuntary eye movement. And an ophthalmologist noticed that her patient's forehead wrinkles are disappearing after she's giving the treatment. She told her dermatologist's husband, and now we have a multi-billion-dollar cosmetic application. Countless wrinkles gone. Testing sildenafil in 1992, volunteers began reporting a peculiar side effect. Suddenly, the world has Viagra. Countless, I think I'll skip this one. A more recent example, semaglutide, better known now as Ozempic. 2016, they were testing it for diabetes type 2 when they noticed its weight loss properties. And now we have a new method to address obesity. Now, these stories of accidental clinical discovery stuck with me throughout my medical training. And I keep wondering, how many did we miss? How many potential drugs could have been discovered earlier? How many patients could have given us the keys to the next antibiotic or the keys to an effective therapy for preeclampsia, a leading cause of maternal mortality? And what if we didn't leave these discoveries to chance? What if we could move from the accidental and towards the purposeful and the intentional and the systematic? And just what if, instead of learning by chance from one unusual case, we could learn by purpose from thousands of unusual cases? These questions stuck with me. So we gathered 10,000 patient records from clinical studies, and we began reviewing each patient record to identify unique and unusual outcomes or presentations. Imagine 10,000 patient records, each requiring hours of careful review. I mean, that's years of dedicated work. We kind of needed a better way. Otherwise, we would spend years just looking for a single glimpse on one disease area. So we really had two options. We could either hire, with a lot of money, 30 clinical experts to review each patient record individually, or we could somehow use the computer. How would the computer actually help in clinical discovery? A process that, it hasn't changed since antiquity. It requires a very unique set of circumstances. The right patient sees the right doctor at the right time. We needed to simplify. So we asked ourselves, what is at the heart of all of these discoveries? What is a common thread? The surprise, the unexpected. As humans, when we see something unexpected, we're wired with this desire to understand why. Why? Why is the world behaving in a way that does not match our understanding? Now, unfortunately, we cannot spark a desire to pursue knowledge in a machine. But what we can do is make it mimic the process in which we humans identify when the world is acting unexpectedly. We can ask it to go through thousands of patient records and identify the unique ones that are atypical and unlike anything rest. With that, a clinical expert can have a much easier time looking through these 4 cues of clinical discovery. We applied this method to our data set and narrowed down 10,000 patient records to 302 records. Of these, we identified 5 novel hypotheses that we're currently testing. Now, I hope you have noticed, I did not say AI or artificial intelligence yet. Even though, by the common definition of AI, a machine performing tasks that are commonly associated with an intelligent being, this would certainly apply. There's a reason. Because it's not about the inner working of the machine. It's about augmenting our ability to discover. It's not about solving for the technology. It's about solving for the problem of finding patients that can broaden and deepen our understanding of medicine. We hear a lot about AI nowadays. We hear that it will usher in the new industrial revolution. It's not merely a tool, it's a transformation. And in all honesty, the hype is not completely uncalled for. But how can we make sure that the promising solutions of today won't end up being the problems of tomorrow? How can we prepare for a world of machine learning algorithms, of AI? The FDA recently published a discussion paper looking at the use of AI in drug development. Now, within clinical research, they identified recruitment, site selection, data analytics and management, adherence tracking, endpoint assessment, and post-market surveillance as areas that have seen concrete efforts of AI implementation. There are a number of other efforts out there that try to take this even further. You may have heard of something called the digital twin or in silico trial that claim to reduce the need for human trials. Now, all of these examples that I just gave you fall under a category of AI called predictive AI. There's another category of AI that really captured our attention recently, generative AI. Large language models producing text based on the data that they were trained on. And generative AI has, I believe, in my own opinion, and I believe you all might have other potential use cases for it based on your experience, but I see generative AI being useful in few areas in clinical research. These can be, for example, quality management system, where it can improve information retrieval, it can improve document control, it can improve training, it can improve event management. I wish I had such a system in my old job. Computer system validation. Maybe we could generate and run test scripts. Do we even dare to say goodbye to taking screenshots of test results and pasting it in a Word document? Hopefully. There's a lot of excitement about using large language models to produce the reports associated with clinical trials. For example, clinical study reports. When building the protocol for a clinical trial, it's very important to find evidence to support each aspect of the protocol, including exclusion criteria, outcomes, validity of outcomes, minimum important difference, sample size. Generative AI can help in retrieve and summarize this information. On the side of the regulator, they can summarize and answer questions related to the submission. The challenge of how do we eliminate hallucinations. And hallucinations in large language models are basically false information based on non-existent data. Sometimes you can even call them fake news. Now, if the promises of AI hold true, I'm just imagining a world where a sponsor is running the clinical trial using patient-generated, computer-generated patient simulations, and produces the report using AI, and then sending it to the regulator that summarizes and assesses the report using AI. I wonder where the role of humans going to be. And the interesting part is the AI that you see today is the worst AI that you will ever see. The capacity of AI will only increase from now on. And the future of clinical research will have some type of AI implementation in it. And it will definitely have some kind of a regulatory framework around it. In fact, the FDA has already been suggesting using the machine learning standards from medical devices into AI in drug development. These would include the VNV40 and the good machine learning practices. I see the future of clinical research in the era of AI going down 3 roads: the wonderful, the same, and the dangerous. The first road, the wonderful. It's a future where we are free to pursue what we're good at: scientific inquiry, empathy, ethical judgment, where we have time to care for our patients and listen and learn and apply those learnings from our patients to improve our care, where we'll never get lost in a mountain of paperwork, data entry, query management, figuring out why there's a duplicated date on every form, looking into endless tunnel of information just to find that protocol that hasn't been updated in several weeks. But, we would be free to pursue what we're good at. And in that future, clinical research would actually be more about patients, more for patients, in a future where clinical discovery and development is streamlined and therapeutics and drugs are accessible, affordable, and personalized. Now, the middle road is just same old business, just an additional layer of technology that we'll all have to take training sessions on, renew our certificate every couple of years, book time in our busy schedule to feed it information, and just otherwise force ourselves to use it because, frankly, we spent a lot of money on it. Now, the dangerous, the third road. Now, at the extreme, one can argue that AI should not have a place in human-centric clinical research. And there are areas of concerns. We've already seen an algorithm implemented to predict sepsis that had poor model performance and caused significant waste of healthcare resources and needless anxieties. What happens if we implement AI in patient recruitment? How can we make sure we're not going to make diversity and disparities in clinical trials even worse? Can we trust AI to tell us when a patient enrolled in a clinical trial requires rescue therapy? When communicating data to safety monitoring boards or the regulator, hallucinated data and misinformed decisions will affect patients worldwide. What can we do to make sure that the future of clinical research in the era of AI will follow the first road more often, avoid the middle, same old road, and eliminate the path of destruction? 3 principles. We must stick to transparency, simplicity, and augmentation. We must start with transparency. There's a very good story that illustrates that need, COMPASS. COMPASS was an algorithm that the criminal justice system used to predict the risk of reoffending. However, it was a proprietary algorithm, so only the company selling it knew how it worked. ProPublica investigated the algorithm and found large racial biases, where the system misclassified black defendant as more likely to reoffend and white defendants as less likely. Now, any human system is biased. And when we implement AI into that system, we don't just merely continue the bias, we amplify it. Had that algorithm been transparent from the beginning, amplifying this injustice could have been avoided. For transparency, we need to know the algorithm, all of the algorithms that make up the AI model. We need to know the data that the AI model was trained on. We need to know all of the model performance and diagnostics. This would create trust and allow us to assess risks and biases. Simplicity. Some of you will remember this. This is Microsoft Clippy. You have to give it to Microsoft. They were visionaries. 1996. Yes, we're that old. 1996, a personal digital assistant. Well, Clippy was intrusive and had very complex workflow. And it ended up doing the exact opposite of what was intended. It hindered users instead of assisting them. Clippy was retired. While we do need transparency in the back end, on the front end, a good AI is an invisible AI. It addresses a human-centric problem and reduces user burden, almost indistinguishable from magic. The genius of AI is not in its complexities, but in making the intricate effortless. Third concept, my favorite, augmentation. Every successful adoption of technology in human history has been about augmenting our abilities as humans. The internet enhanced our ability to communicate. Search engines enhance our ability to find information. Medical diagnostic devices enhance our abilities to diagnose diseases. AI should not be any different. In fact, if we aim for AI to replace us instead of augmenting us, then we're setting up the technology for failure. Babylon Health, once a $4 billion company, aimed to replace a flesh and blood clinicians with an algorithm. Babylon Health is now in bankruptcy. We shouldn't aim to replace doctors. We should aim to make doctors' life easier, to make their work better. We should not aim to replace sites, research coordinator, much less patients. The goal of AI is to help and assist users, sometimes gradually and incrementally. Make up the form, fill up the form for us so we have more time to spend with the patient, or sift through thousands and thousands of records so that a human researcher can find novel discoveries. This is the ultimate goal of AI, to augment our ability to perform human-centric research, to amplify humanity, not to replace it. This is why we need AI, to augment. This is why it has to be transparent and it has to be simple. It is because behind every medical marvel, every successful drug, there's a patient. And AI has the power to allow us to refocus our attention on what matters the most, the patient. And this is the ultimate why. Thank you. I can't wait to see the innovations in this space.